Okay, my name is Kumar Sankaran, and I'm the Vice President of Software and Platform Engineering at Ventana Microsystems. And in this demo, we'll be talking about storage acceleration with SPDK on RISC-V. So I'll cover some of these terms that we're going to talk about today, and then we'll dive into the real-time demo. And so the two applications we're showing today is NVMe-oTCP and Ceph, and both of these are used in storage applications across the board. NVMe-oTCP, what exactly it is? It's an extension of the NVMe spec, and it defines bindings for the NVMe protocol for message-based fabrics like TCP. And it provides a low-latency TCP-based transport interface for a remotely connected storage device such that it appears as if it's connected locally. Ceph, it's a software distributed storage platform, and it provides object, file, and block level storage. It's open source, fully available under the LGPL v2.1 license. And SPDK stands for Storage Performance Development Kit, and it's a framework to accelerate storage workloads with high-performance libraries and tools provided in user space in Linux. And again, this is open source as well, provided under the BSD3 clause. And the applications, we'll be showing two applications. One is a video streaming application, where you will see a video being streamed between two hosts and using NVMe-oTCP. And the second one will be an example Ceph. And this would be accelerated with, both of these would be accelerated with SPDK. So going to the stack itself, how does the software stack look like? So here is the software stack for the first demo, which is the NVMe-oTCP with SPDK. The right side is what is a typical NVMe over Fabric initiator or client, and that runs on a regular x86 Ubuntu laptop or Ubuntu machine. The stack there looks very traditional. So it's got a BIOS, an EDK 2.1 BIOS, runs Linux on top, and then on top there is a user space application that is just going to stream a video application. And then on the left side is where the real meat of it all is, and that's what is the RISC-V QEMU platform. And that again has a UEFI-based BIOS, a Linux kernel, and then on top of that is a user space SPDK, which accelerates storage. And the SPDK engine or block has an NVMe over target TCP and a block device and AIO framework that talks to the Linux kernel using what's called the UIO-PCIe block, right? So that's the interface to the kernel from SPDK. So this is the stack for the NVMe-oTCP plus SPDK demo. And then we will go to the next one here, which is Ceph. So Ceph, I think some of you might be familiar with how Ceph works. So again, working bottom up in this picture, the bottom platform is the RISC-V QEMU platform, and it has a locally attached NVMe SSD, and the BIOS is a UEFI EDK 2.1 BIOS, Linux kernel that has UIO-PCIe and the NVMe block. And then on top of that is user space Ceph. Ceph runs in user space. And you can kind of see there are two OSDs, or object store daemons. One is accelerated using SPDK. The other is a traditional NVMe framework in the Linux kernel. So that's the two black arrows that you see there. There is one monitor node and one single Ceph client. And we'll also see the dashboard web UI that Ceph has, right? So we'll launch this and we'll see the web UI as well. So let's dive into the demo here. It's a recorded video, but I'll talk through the video while you see the stuff happening live. Okay, so the first thing is, before I start here, okay, so the screens that you see here, okay, you can see the screens. The two screens you see on the left side of the screen are the consoles on the target, which is the RISC-V QEMU system. And the two screens you see on the right side are the ones on the client side. So the client side is running on an x86, like a laptop. And the left screens are actually the RISC-V QEMU system, right? So what we'll do first is we'll boot the whole system and then go from there. Okay, so the first thing we do is we boot the Linux on the QEMU side, which is what you see booting right now. And it's booting Debian. And it's pretty much a full-fledged root file system that comes with Debian out of the box from upstream RISC-V. And yeah, once it boots, we would log in. And yep, there you see it's a QEMU-based system, and then you will see the releases as well, which should show Debian. Yeah, it shows a Debian kernel there. And then we'll start on the bottom will be the SPDK demo. So when the NVMe over Fabric starts on the server side, we'll go to the client side and initiate the client to communicate with the server, right? So the server side has started, and the client has started here. And once the client starts, it'll connect to the server on a socket that the server is listening on, and you'll see the connection being established right there, you see. And once that happens, you can actually see that the remote file system is mounted locally on the client side. So right now what we'll do is we'll just create one file on the server side. We'll just call it server side, create a file, and then we'll see that on the client side and see that the file is the same. So we create a file, we just mention the contents as server side file, save it, and then, yeah. And then if you list it, you see the file there. This is again on the server side. Sync the disk, so the disks are flushed, so the remote end can see it. And then we go to the remote side. This is the client side. You list the file there. Again, sync the file system first. And then we list the contents first again. Yep, you see the file there, which is the server side file we created on the server side. And when we list it, we see the file. Next is we'll launch a video demo where we'll stream a video from the server to the client.
My bad luck is biblical. I'm not even trying to kill people and someone dies.
Remember the suicidal belt?
That's too easy.
Shit.
What?
Remember those two wackos from the Bolivia job?
The twins?
Yeah, not so sure they're twins.
Get off the train.
You stab me?
I would never start going fight.
White Death with his army of assassins.
There's this soulless psychotic leader with the largest criminal organization on the planet.
I don't see the White Death letting any of us off this train.
We need to come up with a plan.
I'm not gonna hurt people.
Okay, so this was a video the client streamed from the server side. Next is we'll move to the Ceph demo pretty fast, quickly here. So Ceph takes a while to start, so we'll skip the startup process so that in the interest of time here. So you see the Ceph node is starting up here, and this is a typical GUI for the Ceph node. And this is the monitor client. When Ceph starts, this is the monitor GUI. You can see two OSDs, and as part of this cluster, one of the OSDs is accelerated using SPDK. The other is the traditional NVMe framework within Linux. And there is one manager and one monitor. These are the two OSDs that you see, and we'll double click on the first one. The SPDK storage is about a 1 gigabyte partition total. And as we scroll down here, you see it's a Debian root file system, and it's accelerated. There you can see it's accelerated using SPDK. So this is the SPDK partition. And the second one is the traditional partition that runs on the Linux NVMe framework, and that's 800 megabyte. And this is again running a Debian root file system. Okay, as we scroll down here, you'll see the rest of the properties of the OSD itself. Okay, back to the monitor node. And this is how the monitor node looks and the configuration. That's pretty much the end of the demo. And so the whole idea here was to show the maturity of the RISC-V ecosystem on the software side, right, on the storage side. So we have all these things available today in Debian. There are other root file systems or distros that we have this working as well. So just wanted to show the maturity of the soft storage ecosystem concerning RISC-V. We have a booth here with Ventana, so come by if you have any more questions. I'll be there. If you want to have these demos locally, we can make that available to you as well. And yeah, if you have any further questions, do feel free to stop by. Thank you.